Okay, so in this video I will explain briefly the data logger version 1.5.0 and 1.5.7. And so what do they do and how do they differ? So the 1.5.0 is an extension from the original reading or scanning code that if you have watched an earlier video that you'll find some similarities such as over here I'll point out this portion is listing the all the serial ports on a system such as Raspberry Pi and asking the user to select the one that is the correct port. And this is user selection. After that, that port is open, and this is basically very similar to these two programs, shorter programs. It's longer because it also has more data logging features, such as starting here, it asks for the total number of data points, asks for delay between the data points, and it's also asking for the timestamp, whether it's a GMT or your local time, and that is saved together with a data file. And then there's also a method to generate it. This is a data file's name, so 4 numbers with year, and 2 numbers with month, and the 2 numbers with day. So whenever this code runs, it'll grab the current year, month, and date and use that to create a file name. So that will be unique. And then it opens that file name and appends to that file. So if it's already existing, then new data will be written to that file. So there's also more user inputs, such as what are the SDI 12 sensor addresses for the sensors that's attached to the adapter. There's an example 1, 2, 3, 4. There's no space, there's no comma, just 1, 2, 3, 4. That means you have 4 sensors with addresses 1, 2, 3, 4. But what if you have something like I have an address 2 and then address capital A and capital C? Then you'll just type 2AC without any space and hit enter. So then all of those characters are treated as individual addresses. And then there's also a few other questions, whether to collect analog voltages. This is only applicable if you have the USB analog adapter. So this adapter has, besides the 4 SDI 12, it also has 4 high resolution analog inputs. So if you don't have that, you can just answer no. And then here we have something that basically validates the user inputs. If the user inputs are within the SDI address space, then it'll be saying, okay, well, we'll use those addresses. Otherwise, it'll say the addresses are invalid. And then there's also the analog input is basically based on the adapter's address Z. So if that is yes, then we put that address Z also into the list of addresses. So this is the final list of addresses that represent all the sensors, including if you have this USB analog adapter, the lowercase z is also included. Excuse me. And then there's also a for loop to iterate through all the addresses. Each one will be issued an address I exclamation sign, such as 1I exclamation sign. This is just getting the identifications, so it'll print a list of those addresses. And then there's also a printout of the data file name, which is based on the year, month, and the date. And then we start with a data collection loop. So this is the main loop that collects the data, and when say if you want to collect 100 data points, of course you probably want more, then after this for loop finishes, the code actually closes the serial port and also closes the data file. So So basically the for loop is where we're going to focus on next to see what's going on in the for loop, how we're collecting data. So this is where basically whether you selected to use a UTC or you select to use local time. So depending on that, the now is defined as either a local time now or UTC now. So then there's an output string, which is again year, month, date, and also there's an hour, minute, and seconds. So this is the output string is going to be basically date and time. And then more will be added to this output string. So here the for loop iterates through all of the SDI 12 addresses. It takes one address out at a time and use that address to issue an M command. So this is a kind of a default behavior, assuming that the sensor is simple enough. There's only one measurement command, the M. And if you have a sensor that has multiple measurement commands, such as there may be M1, M2, up to M9, then this is a simpler code than that could handle multiple M commands. And anyway, you can always expand on this code. My purpose is not to generate something that can somehow serve everyone, because that will be very long and difficult to understand. And my purpose is to generate something that helps most people. And if you're already feeling like this is okay, this is what you do, you don't need to change anything. If you feel like, oh, I need the M1 as well, then read on and you'll be able to understand and maybe add that command in and collect more data, right? So after issuing that, it reads back the response, and it removes the new line symbols, and then it searches through that line, the response. So what the response actually has is it actually responds with the number of values returned. So if you issue an M command, it'll tell you, okay, this is how many values I'm going to return in how many seconds. Okay, so this is a way to extract that value. The value is basically searching for numerical digits. So the very first encounter is that. All right. So now that this total return value is red, we'll actually be going through this to basically take apart the return values after we issue the D0. Okay, so now we read another line. This line basically is the service request, which means after receiving the M command, the sensor first tells the data logger how many data points, how many time in seconds, and then it also will issue its own address as this so-called service request, just to tell that the data logger that data is ready. So the data logger, our script, is going to issue this D0 command. And again, if you're with most people who don't really have a sensor that returns a bunch of values, the D0 is enough to extract all the values. If you have a very complex sensor that has a lot of different sensing elements on it and different sensing modes, and the D0 may not be enough, you may need to do D1, D2, and so on after the D0. So hopefully with this, you understand how to add those things. So reading this back, this is actually the result. Okay. So now that we have this result, the return values, and we only take a subset of that because we're going to skip over the first value, which is the sensor address, and then skip over the last two values, which are new line symbols. So then what's left is this line that has numbers separated by either positive or negative signs in between, and then we're going to search through this, basically expecting the total amount of values here, and then we're going to search through this line and this m is going to be a new value, basically appending this value to this so-called values list, which starts empty. So basically, what this does is it searches, and it searches out one value, it takes it, and then it turns it into a floating point number. And sometimes the values are not returned, so this may actually fail, and then the failure is handled like this, and no data received, and it'll sleep with the delay time until the next data collection cycle. And it'll also issue this no data is true, and then if no data is true, it just breaks out. The rest of it is assembling data for saving to the file and also uploading to the internet. So if you don't have any data returned, then there's no point. You just start from the top again, try to collect data again. So if you do have results, and then the output string, it already has the year minus date and hour, minutes, and seconds. So it's going to append the address, SDI 12 address, and then it's going to append with all the values received. So there's also this maximum upload value, which is limited by the original online service, which is, let's see, ThinkSpeak. So they only limit up to 8 values to be uploaded at a time. A lot of databases don't have that kind of limitation, but they do. So we're basically just cutting things off. If you do have 9 returned values from multiple sensors, only the first 8 are uploaded. So this is only for that purpose. Okay. So the value string is just going to end. Otherwise, it just keeps adding. And here, if no data is true, just return it to false and continue on. And here we also have, let's see what this is. This is basically making a value string with the value string add the field, and also there's a number. This is basically for ThinkSpeak posting, and then we want to print it out for some inspection, and add a new line, and we write this to the data file. So this looks good enough, which is adding all the strings together with the SDI 12 address. So we save it, and also we'll take this value string, which is formatted per the ThinkSpeak, and then we'll do a request. We'll just going to do this request here, and depending on whether we're successful or not, if there's an exception, well, we'll handle that, and if there's no exception, then we can expect that data have been sent, and then we'll just we'll flush the data file, which means the data gets saved onto the drive instead of staying in buffer, which could get lost if power is lost, right? So then we also do a sleep, and then we set values equal to empty. This is probably not entirely necessary because the values start here. Let me see, I want to point out here as empty, so doesn't really matter, and that's it. So this is basically, it's just repeating itself every time after a certain delay time. It starts to do this again. It takes one address from the address pool, or the total amount of addresses that are on the bus, and starts asking one at a time. So that's what this is doing. So the 157, on the other hand, it does something a little different. So if you still remember, at the beginning of this program, there's a lot of questions for the user to answer, such as which serial port, how many total data points, a delay between, and all the other things. So you have to be there to type these in. Of course, there's another way, just to redirect input from the content of a file, but that's you could do that. I've done that before. There's a better way to handle this is this 157. So the 157, besides having better exception handling, it also has this so-called config file. So there's the file name. You can change this to anything you want, but there's a config file. The config file has things like this. So Wi-Fi's SSID, the password, and all the other things such as API key for posting to ThinkSpeak, or you can include other things to post to your own servers. So everything that needs to be entered by the user can now be just read from a config file. And there's also some better handling for exceptions. And here, if we just go further down here, there's a newly defined function called load parameters. So what this does is it tries to open the config file to read it. And if that fails, that means the config file doesn't exist. And then the exception is it turns out, okay, no config file, it'll start interactive session. So it returns a certain value set that the caller of this function will know, oh, there's no config file, let's run an interactive session. So the user can type all this in, which can later be saved to a config file. So next time there will be a config file. So the very first time you have this exception, you'll be asked all the questions again. But once you have this running, so if you stop the code and run it again, you're not asking you anything anymore because it has saved all your answers. Alright, so assuming that it has saved your answers, you'll read it and load it into the parameters directory and close the file and return these parameters. So that's what it is. And this is also defined as print credit. So there's a credit printing, and this is that interactive session, which looks similar to all the earlier versions. This is asking for which port, and it'll print out all the ports, and now you select it. This is where the selection is recorded, and then what it does is it just basically appends this to the ports, and then it also instantiates the serial port, going to append that to an array as well. And then it just asks all the other types of questions, total data points, delay and such, and also there's the SDI 12 address list. So that also gets saved. That is convenient. And here you also have more stuff. Let's see. So let's see. There's printout that says, well, the basic sensors respond to M0 or M, and then more sophisticated sensors could respond to more commands such as M0, M1, and more. So basically, it's going to ask you what kind of commands are you going to send. So it takes all the SDI 12 addresses that you have in input, for instance 1, 2, 3, and Z, for instance, and then for each sensor it'll ask you what kind of M commands you're going to send. Are you going to send just the M or M0? They're the same, by the way. Or you have to send M, M1, maybe an M3. So ask for the individual sensor what kind of measurement commands need to be sent. And then it just basically appends to that. So each sensor will have its address and also the list of M commands, if not just one M command. And this is more, I would say, advanced compared to 150. And after all that is done, see now the config file is opened for write, and it dumps all the content into the config file and saves it. So this interactive session only runs one time until you delete the config file. Say if it's not correct, you want to delete and redo it, just delete the config file and it'll run this interactive session again. Okay, so there's also this other function. This is basically just showing sensors info, makes it easier. Just call this, right? And this is where the main code actually starts at this line 185. So first it tries to load parameters. So the fnf just means file not found. It's just a variable. And if the load parameters fails to find the file, this fnf actually turns true. So if file not found, then run interactive sessions. And else, well, files found and the parameters are loaded, then you can use saved configurations. So it besides saving everything that I said, the SDI 12 addresses, and for each address what memory command you need, it also saves which serial port to open. So that is kind of nice. Right, so it opens the port and it sleeps, and then shows the sensor info. Basically, just pulls all the sensors, each one at a time, to ask for the identification and print out the identifications. And then there's also the time zone selection, which is in the parameters, either interactive session or loaded from the data the config file. Then the data file gets created and opened with a year, month, day, and the rest of it starts to look very similar to this 150, except that there's, well, more than one command, right? One m command. So this is basically is asking the command, and how many m commands do you need for each sensor, depending on which sensor. So it'll issue more than one m command. So that's what it is. That's slightly different. And it's also reading back the responses. And let's see what else it does. It's searching for data. There's no data, breakout. If there's data, how many data the m command is supposed to respond with, basically. And let's see. And then basically we're going to read all the responses. If you have multiple m commands, chances are one of the m commands returns more than enough values for a D0. So the rest of the values will be returned if you issue a D1 command. So in the 150, that was not handled. Only D0 was issued. So over here, we're going to have a range up to, well, this is actually 0 through 9. So D0 through D9. This is if you're extracting a lot of values, D0 only returns you a handful of them, and then the rest you have to keep issuing D1, D2, and D3, and more values are returned until there's no more return value. So this is that logic. So it'll issue a D0 command, and it writes that, and then it reads back the response. So if the response is less or equal to 3 characters, which means something like this is returned, that means the sensor has no more values. You can keep issuing D2, D3, D4. There's no more values, so we can stop. So that breaks out. Otherwise, the response is concatenated together. So if you issue D0, that goes into this line. And then if you continue to issue D1, and that's also going to be added into this buffer. So this response is kind of a subset of the original response, because you want to remove the first character, which is the address. You don't have to have that, and also the last 2 characters that are new lines. So all you have are just pure data, plus minus sign, a value, plus minus sign, value. So you want to concatenate all of these from D0, D1, D2 of a single sensor into this buffer. So that's what it's doing. And now you have this buffer. You can start searching through the buffer and find all the values from the buffer. Basically, identify the values. The values will feature positive or negative sign and numbers. So that's what it looks like. And then you extract those numbers, try that, and try to turn the numbers into a floating point number and append into this so-called values, this values list. So let's see, done. And when that is done, you can start putting output strings together. So basically the original output string plus a comma plus the address, and then each of the output values is turned into a string again and concatenated to the output string. So that is equal to that. So it's concatenation, and this is also doing the ThinkSpeak upload, so it has a maximum number of 8 values to be uploaded simultaneously, which is not the case for a lot of other databases. So anyways, you can ignore that. It's just trying to only collect the first 8 numbers. Okay. So basically, so this loops through all the values that's collected from one sensor, all of the different M commands, and for each command, all the different D0, D1, D2, etc. other return values, they're all chained together into a series of comma separated line. So that's what it's doing, and also an address is put in front, so you know there's an address, a bunch of values, another SDI 12 address, a bunch of values. It's easy to read it in Excel, for instance. So now this is done. It just see that goes back to the next sensor address and does this all over again. And once all the sensors are done, this part is basically putting together an HTTP request and send that request out to the URL, and also the data files are being written. I think that's over here. The entire output string, which contains date and time, and also SDI12 address, a bunch of values read from it, another address, a bunch of values, and so on. So that's a very long line. And that line is written, and then the data is flushed to the drive, and then there's sleep, and then you can basically go back to collect data again. So this is a bit more advanced and also looks a little harder, slightly harder to read, but the advantage is if you run this code, you can set up your Raspberry Pi to almost automate this script, because once you run it once, it collects all the configurations, and then as you start running it twice, it doesn't need you to input anything anymore. It has the config file, so it makes it easy enough to incorporate this into an auto run. And there's a lot of different ways to auto run the script. I suggest you to Google all the different ways and just kind of try out these different ways yourself to find which way is best for you. So I think that's enough explanation of what these programs are doing. And to end the video, I want to say that not everyone has the same exact requirement, and if you're able to just hack the code to make it look exactly like what you need, good for you. I kind of expect a number of people to be able to do that after me explaining through this, and you maybe tinkering with the code a little bit, including the simple ones. So what if you're not able to achieve what you want to do? Say you're trying to upload to a certain database that has some requirements, some sort of formatting, and you're not sure what to do. You can certainly contact me if it doesn't take more than a few minutes to figure something out. I can certainly just let you know how to do it. And if it takes some significant time, especially testing it, then I do certainly have service I can provide, such as consulting, to get to customize the code into something that you need.